Welcome to this short presentation on solid edge piping design for HVAC, air duct and cable tray design. Solid edge piping design is a robust tool which supports 2D piping and instrument diagram, also known as P&ID, which in turn drives the 3D piping design. This is key for plant design with digital twin between P&ID and 3D piping design, with cross-highlighting between the two solutions. This aids the piping designer to build accurate piping assemblies in accordance with the P&ID master data. The solution also supports independently built piping assemblies based on a 3D sketch. Piping specifications with thousands of standard part libraries is provided out of the box, and built-in design rule checks to validate the piping design to selected industry or company standard. Most importantly, it also has a solution for isometric drawing generation, which is quick, easy and highly automated. There are many other areas other than piping design which are key for any plant design, like HVAC, cable tray, air duct design, pipe support placement. This last area is what we will focus on now. Solid edge piping design has a solution for quick placements for pipe supports, and it does provide the standard shape fittings for HVAC, air duct and cable tray design. It also provides the tools to create standard shape fittings and pipe specifications based on a selected standard, which we can then design HVAC, air duct or cable tray parts. Let's see this solution in action. In this demonstration, we are going to show how our solution supports the design and creation of cable trays and air ducts for use within your plant designs. Here is an assembly. We have defined a number of 3D sketch paths along which cable trays have to be positioned. Once the pipe specification and the sketch paths are defined, you can select the paths and apply pipe specification with the required size. We have defined all the different sizes and fittings as part of the pipe specification. Based on the input, i.e. the path profile selection, and pipe specification information, the system creates the cable trays and places the fittings at the shape ends and intersections as defined in the pipe specification. You can zoom in and verify the fittings placed at the joints and intersections. Let's delete the cable tray assembly and see how our solution supports the definition of different cable tray sizes for multiple paths. You can edit the line segments in case the shape sizes are defined from an existing assembly. We can define different sizes for each path segment. In this case, let's define the size as 100 mm from the cable tray specification and update the assembly. Now, select the connected path and define the size as 200 mm from the cable tray specification. The solution not only places the cable tray of selected size, but also places the right fittings at the right location in the assembly. Now let's see how the solution supports different use cases in creating air ducts. We can select all the line segments and select the size as 250mm by 150mm from the air duct specification. Within a few seconds, you can see the air duct assembly is created. You can highlight the fittings on the display to see each fitting name. All the fittings will be perfectly positioned and placed between the air ducts. Air duct assembly will be associative to sketch path and update as and when we modify the 3D sketch. Earlier we changed the size after deleting the shapes. However, it is possible to edit the air duct size without deleting existing shape and fittings. Let's see this workflow now. We can select the line segments to be edited and change the size selection to 350mm by 150mm. The selected air duct assembly gets updated to the new shape and size and all the related fittings. You can preview all the fittings before updating the shape. Thank you for watching this presentation.